All right, so today, lesson 9A, solving absolute value equations. And so far in Unit 1, our big focus has been on expressions and equations. We've done lots of equation solving. We've also dealt with graphing linear equations, which most of you did last year. And so far, we're just restricting it to nice, easy slope-intercept method linear equations. We will eventually get beyond that, but for right now, that's been our restriction. So now we take it equation solving to the next level, solving absolute value equations. And you kind of saw that in today's warm-up. So let's move on here. Remember, ever since you first saw an equation, probably back in the 3rd or the 4th grade, the whole idea was, what can the variable be in terms of a number to make a true statement? What can the variable be to make a true statement? So what about the equation on the left-hand side? What could the variable be to make a true statement, Georgia?
5.
Could be 5.
Could be negative 5.
Could be -5. So this is where the idea that the majority of the time absolute value equations have two answers. In this case, 5 and -5. How about the one on the right?
I don't think there are answers.
Why not?
Because anything you put in between those two lines will become positive.
Yeah, so when you take the absolute value of something, you're never going to get a negative answer. So what is the answer? Yeah, it's not like that's the first time we've run into that. We're going to continue all year long to run into situations that may have that possibility. But let's go into the formal definition of what absolute value means. And in the lower right-hand corner of your notes, you have a little bit of room there. So this is where, in your notes, that's where I would write that, in the lower right-hand corner. So the formal definition of absolute value is this. Absolute value of x is x if x is greater than or equal to 0. What does that mean? Well, what that means is that if x is 0 or above, whatever number's inside your absolute value bars, that's the answer. But if x is less than 0, in other words, if x is a negative number, that means the answer will be the opposite of that. So once again, this is just the formal definition of what absolute value means. So a couple of examples here. The absolute value of 5 is 5. The number that was inside the absolute value bars was 0 or bigger, so the answer to that was just the number itself. Whereas when we have the absolute value of -5, or the absolute value of a negative number, which is basically what this part is saying right here, if x is a negative number, then it's the opposite of the number that you see between the absolute value bars. So the absolute value of -5 is the opposite of -5, which is 5. And I think that's fairly obvious. But I just wanted to see or show you how that correlated to what the formal definition is. But this is the problem right here that we're going to run into, and you're going to hear me say this a lot this year. Sometimes students go into automatic pilot, whereas they just go through the process and they don't think about what they're doing. So anytime you have the absolute value of anything, you are never going to get a negative answer. So make sure that you realize that that will always be no solution. Okay? I'm going to stop for just a second to let everybody get caught up here. All right, so let's start with number 1. Number 1 is the absolute value of x minus 3 is equal to 15. So as we saw in the warm-up, and I mentioned this, that most of the time absolute value equations have two solutions. So how do we find both of those solutions? Well, the first thing we do, and you really should take very good notes on these first few, we're going to split this up into two equations. The first one is x minus 3 equals 15. The second one will be x minus 3 equals -15. So, to make this very clear, the left-hand side is always just the part that's inside or between the absolute value bars. The right-hand side is whatever this number was, and then the opposite of that. So these two answers, if you want to think of it that way, are opposites of each other. I'm not saying the answers to the equations are opposites, just the setup. Those two are opposites right there. So when we get our two equations, now we just solve both of them. So everybody solve both of your equations. And of course, in the left one, to solve that, we use the addition property of equality. We add 3 to both sides. So in the left-hand equation, what do we get? Just say it.
18.
X equals 18. And in the right-hand equation, we have to use the addition property of equality once again. We add 3 to both sides. And what does that equation give us? Negative 12. Now, the first common mistake is to think that once you get 18 for the first one, well, the second one is automatically negative 18. No, most of the time that's not true. So you have two choices at this point. You can write your answer like this, or I'm going to show you a shortcut way, if you want to think of it, of writing equations that have multiple answers. And that would be by using braces like this. And this is the preferred way, usually, of writing answers or solutions to equations that have more than one answer. Now, the only thing is, if you're going to write your answer this way, you need to make sure you go in numerical order. So smallest number to the biggest number. Okay? So the answer to this, and we will be sent as framing this in a few minutes, the solutions are negative 12 and 18. Yes?
So you don't put like the x equals or anything?
If you want to, that's what I was saying. You have two choices, right?
Yeah.
You can write your answer like that, or you can write it like this.
You don't have that for the brackets.
The braces?
Yeah.
You don't have to write braces if you don't want to. That's just kind of a shortcut way, a faster way of writing answers when you have multiple answers. Okay? All right, everybody try number 2. We're going to split this up into x plus 8 equals 6, or x plus 8 equals negative 6. In the first one on the left, use the subtraction property of equality. We get negative 2. Second one, use the subtraction property of equality. We get negative 14. So the solutions are negative 14 and negative 2. All right, try this one. So once again, some of you went into automatic pilot. You tried to split it up, but you should have noticed that you have the absolute value part by itself equal to a negative number. That can never be true. Therefore, no solution. Okay? All right, so let's keep going here. Now, number 4. Notice that the absolute value part is not by itself. So the general rule of thumb is, let's get this part by itself. That way I can easily then split it up into 2 equations. So if I want to get that part by itself, what would I have to do to make that happen? Subtract 7 from both sides. So that part of it is just like solving a regular equation. So when we use the subtraction property of equality, in other words, we subtract 7 from both sides, now the absolute value portion is by itself, and now solve like you did in number 1 and number 2. So I will let you finish it from there. So obviously you should have split this up into 2x minus 3 equals 25, or 2x minus 3 equals negative 25. And Peter?
I got negative 11.
Wait, I got?
My answer. Oh, the solutions are.
There we go.
Negative 11 and 14.
There you go. Okay, good. The one on the left, addition property of equality, then division property of equality, and we get 14. In the second one, addition property of equality once again, and division property of equality, and we will get the solutions are negative 11 and 14. All right, try number 5 all the way through. All right, Emily, obviously we had to subtract 4 from both sides first, right, to get the absolute value part by itself. Then we split it up into 3x minus 2 equals 17, or 3x minus 2 equals negative 17, right? Then what'd you get?
I got the solutions are 19 over 3 and -5.
Okay, and then if you're going to write it in braces, just make sure you put the -5 first. Okay. So we add 2 to both sides, then divide by 3. There's where the 19/3 comes from. In the second one, add 2 and then divide by 3. That's where the -5 comes from. So if you're going to put it in braces, make sure you put them in numerical order. All right, number 6. Give it a shot. Once you subtract 10 from both sides, we now have big problems. We have the absolute value of something supposed to be equal to a negative number. That cannot happen. You need to keep your eye open for that. No solution. All right, number 7. Remember, what we're trying to do before we split things up is we really want to get the absolute value part by itself. Now, somebody asked first period, well, can't you just distribute through? Well, you have to be very careful with that, because I could create a problem for you where that would lead to big problems. So my advice, don't distribute. Get the absolute value part by itself. So in this one, how are you going to accomplish getting that by itself? Divide by 3. Those things are the same things you guys have been doing for several years. So if you divide both sides by 3, you end up with the absolute value of x minus 4 is equal to 6. And now I will let you quickly finish it. So obviously we're going to split that up into x minus 4 equals 6 or x minus 4 equals -6. Equation on the left will give us 10. After we add 4 to both sides, the equation on the right will give us -2. And so the solutions are -2 and +10. All right, here's what I want you to do right now. Number 8 and number 9, do both of them. And then we will shoulder partner answers in about a minute and a half. So go ahead and do number 8 and number 9. Number 8. We need to get the absolute value part by itself. We can accomplish that by either multiplying both sides by -1 or dividing both sides by -1. I'm going to divide both sides by -1. And when I do that, of course, what happens is that sort of cancels that out. So that's why the absolute value part is by itself. Now you can see that there is a solution. So split it up. Solve both of them for x. The one on the left will give us -2. The one on the right will give us -16. So therefore, the solutions are -16 and -2. In number 9, it's kind of like a 2-step process to get the absolute value part by itself. We would subtract 7 from both sides, then divide both sides by 3, which gives us the absolute value of b minus 2 equals 1. Split it up and solve. And I can see from this that we will get the solutions are 1 and 3. So any questions there? Okay, so we've got 2 problems left. Let's go to the back side. And the key part here in both this word problem and the next one is that it says to write an absolute value equation that would give us what we need here. Now, when we're doing this, we need to set up an equation that will look something like this. So you probably should write this down because this is true in both of these word problems. What we're going to do is we're going to set up the absolute value equation to look like this. It's going to be the absolute value of x minus the desired point that says the absolute value of x minus the desired point. It's kind of hard to read that, but that's what it should say. And that is going to be equal to the desired distance. So the absolute value of x minus the desired point is supposed to be equal to the desired distance. So what I would like you to do is I would like you to take a look at the word problem and see if you can come up with what you think the absolute value equation, what that might look like. So I'll give you about a minute to figure that out. Once again, what that means in terms of this problem is the absolute value equation should be x minus 690 is equal to 6. So once again, that would be what the absolute value equation would look like. Now from there, we've solved enough of them that that part should be easy. Split it up and solve. And most of you might be thinking, well, yeah, I think I probably could have figured that out without setting up any sort of equation. But once again, the point is that my guess is that there will be more questions on SBAC testing that only ask you for an equation rather than an answer. So if that's the case, we're looking for something that looks like this. Yes?
How do you know that 6 is positive?
Well, it's within 6 golf balls of the 690. Okay? Within 6. Now, obviously, if it was negative 6, that would be no solution. But that's we know that there's a possibility here, right? Okay, so now, let me sort of summarize this. And I know that you have a sentence frame here where you have to fill in a blank spot. But when setting up a word problem involving absolute value, remember that absolute value can represent distance from a given point. So, the difference between the answer and the desired point in that last problem, 690, is placed under the absolute value symbol. So, that's where that came from. This absolute value is then set equal to the desired distance, which was within 6 golf balls. That's where the rest of that came from. So, if you did not write this down earlier, you should now. So, that comes from the difference between the answer and the desired point equal to the desired distance. So, at this point, I want you to read the last problem, number 11, and come up with the absolute value equation that would represent that problem. All right, so number 11 says a machine fills Quaker oatmeal containers with 32 ounces of oatmeal. After the containers are filled, another machine weighs them. If the container's weight differs from the desired 32-ounce weight, and that was a big hint right there, by more than 0.5 ounces, the container is rejected. Write an equation that can be used to find the heaviest and lightest acceptable weights for the Quaker oatmeal container. And I wasn't as concerned about the solving part of it. And this is exactly what most of you got. The absolute value of x minus 32 is equal to 0.5. At this point, after doing so many problems, we know how to easily solve. So the heaviest is 32.5 ounces, the heaviest that they will accept, whereas the lightest that they will accept is 31.5 ounces. All right, quickly turn to your shoulder partner. The ones will start the conversation. I only want to spend about 20 or 30 seconds on this. What did you learn today? Just a second ago, you said, I learned how to solve absolute value equations. That's basically what we did.